Consider the reaction below. Predict with reasons what you would observe if the reaction mixture was heated. The forward reaction, that is the reaction from left to right, is endothermic. We can see this is a reversible reaction, and this means the reaction tells us how much products and reactants it has, and that it's constantly changing the amount of products and reactants, and it's changing reactants into products all the time and vice versa. Reversible reactions have an interesting feature about them. If you change the temperature of the reaction or the concentrations of the reactants or products, the reaction will change the ratio of products and reactants to try to counteract the changes we have made. If we heat a reaction, it will make more products or reactants to try to cool down the reaction. If you cool down a reaction, the reaction will make more reactants or products to try to heat up the reaction. We can predict what the reaction will do by looking to see if the reaction is exothermic, i.e. it gets hot, or endothermic, that is, it gets cold. In a similar way, if we change the concentrations, the reaction will try to make more products or more reactants to try to keep the concentrations the same. We're going to look at what will happen if we change the temperature first by using this reaction as an example. Consider the reaction below. Predict with reasons what you would observe if the reaction mixture was heated. The forward reaction, that is the reaction from left to right, is endothermic. The first thing we notice about this is it's a reversible reaction. So the reaction can go forwards and backwards. The substances on the left hand side are pink and the substance on the right hand side is blue. Because we've been told that the reaction from left to right is endothermic, that means that reaction there gets cold. That must mean the reaction from right to left is exothermic. So let's think of it this way. The reaction is made of two sides, the left-hand side and the right-hand side. The forward reaction, that is the reaction from left to right, is endothermic, which means the reaction goes from there to there. It's endothermic, the reaction gets cold, which means that when the reaction goes from the blue to the pink, the reaction gets hot. The question asks, what would you observe if the reaction mixture was heated? So if you heat the reaction wants to do the opposite. If you heat it, it wants to get cold. How does the reaction mixture get cold? That changes the ratio of the products to the reactants. That means that we have more of the reaction going from this side to this side. The reaction gets cold, which means it makes more of the blue if you heat it. So what you would see is the reaction mixture would turn blue. So the question is asking, what would you see if you heated the reaction? So what we're going to do is work out if the forward reaction is exothermic or endothermic. We're going to work out whether the forward reaction gets hot or cold. We're then going to predict if more products or reactants will form, and then we're going to predict the colour. So the question tells us that the forward reaction is endothermic, and that means the backward reaction is exothermic. Because the forward reaction is endothermic, the forward reaction makes the reaction colder, but the backward reaction makes the reaction hotter. Part 3. Remember that if you change the temperature or concentration in a reversible reaction, the reaction will try to make more products, or the reaction will make more reactants to counteract the changes that we have made. So because we have heated the reaction will want to get colder. Part 4. Because the forward reaction is endothermic and the forward reaction gets colder, we will get more products. Part 5. Because we're getting more products, the reaction will turn blue. Let's test our prediction. The beaker on the left-hand side is cold water, the beaker on the right-hand side is hot water. Remember now, because this is a reversible reaction, if we change the temperature or the concentrations in the reaction will either make more products or it will make more reactants to try and counteract the changes that we've made. Because the forward reaction in that direction is endothermic, if we heat the reaction, the reaction will want to get colder. And because the forward reaction is endothermic, the forward reaction makes the reaction colder. So we predict that if we put our pink into the hot water, it should become blue.